For this lesson, 4.6, we're actually going to call this 4.6a. All right. And what we're going to focus on here is, can you write equations from roots? I want to be able to solve equations by taking square roots. And then we're going to focus on just learning a technique called completing the square. All right. Now we'll come back and do a lesson 4.6b where we'll finish up the remaining things on here. All right. So how do I write equations from roots? The first thing that I want to do is write the roots as binomials. In other words, you use that thing called the zero product property, right? And then multiply the binomials. This is very simple. Let me make sure that you guys all see how this works. So if I know that the solutions, or the roots, are 5 and 3, that means x is equal to 5 and x is equal to 3. Now I have to kind of think in reverse order. Where did those come from? Well, they came from x minus 5 equals 0 and x minus 3 equals 0. In other words, I set them equal to 0 or wrote them as binomials. I take those two binomials, x minus 5 and x minus 3, and I multiply them together to give the quadratic from which they came. So this would be x squared minus 3x minus 5x plus 15 equals 0, or x squared minus 8x plus 15 equals 0. All right, so it's almost like you do the exact opposite of what you did in order to solve a quadratic equation by factoring. You almost reverse the process. So let's take a look at this second one here. I'm going to draw a little line so I don't overlap here. I know if x is equal to negative 4 and x is equal to 4, will tell me that this came from x plus 4 equals 0 and x minus 4 equals 0. I'm going to multiply these together. X squared minus 4x plus 4x minus 16 equals 0. And then combine my like terms, and I'm left with x squared minus 16 equals 0. This is the quadratic that those roots came from. All right, let's try one more here. So if x is equal to 3 over 2 and x is equal to negative 2, when we have that fraction, I have to remember how we were doing that technique. But it came from 2x minus 3, and then x equals negative 2 came from x plus 2. All right, I multiply, and I get 2x squared plus 4x minus 3x minus 6. Combine like terms, I have 2x squared plus 1x minus 6 equals 0. All right, let's try another one here. What if the quadratic only has one root? Well, here's the key. They tell us it's got to be a quadratic. So if the quadratic only has one root, it actually has the same root twice. Where did this come from? It came from x plus 6 times x plus 6, which would be x squared plus 6x plus 6x plus 36 equals 0, or x squared plus 12x plus 36 equals 0. All right, so the first thing is, how do I write an equation from a root? That's the process. It's pretty simple. The second test we've got for today is to solve quadratics by using square roots. All right, so a square root basically means we're going to go back to the root of a number. Now, if any of you have difficulty with simplifying square roots, this is a skill that I assume that you had in the past. Okay, if not, let me know and we can do some extra work on it in class. All right, the only time that you can use this technique to solve a quadratic is when there is no b value. In other words, that x, or that middle term from standard form, is gone. So how do I do it? First step, solve for x squared. We want to get x squared all by itself. We want to get rid of any values in front of x squared as well. All right. We're going to take the square root of both sides, and this is the big key. When using square roots, we have to show two possible solutions. We're going to use the symbol positive, negative, or plus, minus in order to represent that. And then we're going to simplify each square root if we need to. All right? So in this first problem here, solved by square roots, I have to get x squared by itself. So the first thing that I'm going to do is divide both sides by 5. That leaves me with x squared is equal to 16. Now that I have x squared all by itself, I can take the square root of x squared to get to the root of that value. And the root of that value would be x. But just like in all solving, whatever you do to one side of the equation, you do to the other. So I'm going to take the square root of 16 as well. Keep in mind what that squared, or that 2, indicates is we have to come up with 2 answers. So I know that the 2 answers are going to be a positive and a negative square root of 16, which is 4. All right. If I take 4 and substitute it back into the original equation, I get 80. If I take negative 4, square it, multiply it by 5, I still get 80. I have to show all possible values that could make this equation work. That's why we're using the plus minus. All right. Take a look at this next one here. So on this next one, I've got to get x squared all by itself. I know square roots will work because there's no b value. So I'm going to add 40. 5x squared is equal to 40. And then I'm going to divide by 5, and I get x squared is equal to 8. X squared is now isolated, so I can take its square root to get x. Whatever I do to the left, I do to the right as well. Now, the square root of 8 actually comes from taking the square root of 4 times the square root of 2. And because I know the square root of 4 is 2, this is how I simplify a radical. So I know x is equal to plus or minus 2 radical 2. Again, simplifying a square root should be something you know. If you don't, let me know in class, and we'll go over and I'll do a little presentation for you guys on that. All right? So what about a special scenario where we have to solve by square roots? All right? If you remember, there were those 3 special case factorizations, and one of them was called a perfect square trinomial. If I factor a quadratic, and that quadratic becomes a perfect square, that means that it's going to be a binomial square. All right? I'm going to solve this just the same way that I did the ones right here. I'm going to solve it the same way. So let me kind of point this out. If I look at the first one here, I know that x squared plus 6x plus 9, if I factor that, it will factor to x plus 3 times x plus 3. But I'm going to write this as x plus 3 squared. And that's equal to 1. All right? I now have that same scenario that I did before. I have a perfect square equal to a value. So I'm going to take the square root of this. Now that leaves me with x plus 3. I also take the square root of 1, and this is where everybody makes their mistake. You've got to remember positive, negative representation. So I know this is really 2 answers, positive 1 and negative 1. I'm going to solve for x by subtracting the 3, and that leaves me with this scenario, negative 3 plus or minus 1. This is really 2 combining of like terms, if you will. In other words, I know that the 2 answers, we still have to go one more step. I have negative 3 plus 1, which would be negative 2, and negative 3 minus 1, which would be negative 4. These are the solutions to that quadratic. In other words, these are the 2 locations where that's going to go through the x-axis. Sorry, I had to get a quick drink there. All right, take a look at the next one. I recognize that trinomial on the left can factor to x plus 4 times x plus 4, x plus 4 squared. That's equal to this fraction, 16 ninths. Because I have a perfect square on the left, I can take the square root. That leaves me with x plus 4. I also want to take the square root of the right side. Square root of 16 is 4. Don't forget the plus or minus. Square root of 9 is 3. So the square root of 16 ninths is 4/3. All right. I'm going to move that 4 over. So I have negative 4 plus or minus 4/3. But I'm going to make my computations a little bit easier. I'm going to change that negative 4 into negative 12/3 plus or minus 4/3. Why? Because now I've got common denominators. All I have to do now is focus on the numerators. So let's see. We have negative 12 plus 4. That'd be negative 8/3. And negative 12 minus 4, which would be negative 16/3. All right, let's try a couple more of these just to make sure we got it down. All right, take a look at this next one. This next one is a perfect polynomial on the left. So it's going to factor to 5x plus 1 squared. And that's equal to 9. Because it's a perfect square, I can take the square root, and that leaves me with 5x plus 1. Whatever I do to the left, I do to the right, and the square root of 9 is plus or minus 3. Again, we're using this because we're solving by square roots. It's a unique technique. All right? I'm going to subtract 1. So I have 5x equals negative 1 plus or minus 3. And then I'm going to divide by 5. So I have x is equal to negative 1 plus or minus 3 divided by 5. All right, I got to clean that up now. I have negative 1 plus 3. That would be 2 over 5. 2/5. Negative 1 minus 3. That would be negative 4 divided by 5. Negative 4/5. All right, let's try one more like this. I notice the left side can factor to 3x plus 4 squared, and that's equal to 36. I have a perfect square on the left, so I can take the square root. I'm left with 3x plus 4. I'm going to take the square root of the right. I get plus or minus 6. I'm going to move the 4. 3x equals negative 4 plus or minus 6. I'm going to divide by 3. Negative 4 plus or minus 6 divided by 3. And now I'm going to clean it up. Negative 4 plus 6 is 2/3. Negative 4 minus 6 would be negative 10/3. All right, so one last thing that we're going to do here is this idea of something that is called completing the square. This is going to be where we'll pick up on lesson 4B, but I want you guys to already start to get a little practice at it, okay? What we're going to try to do is if we have an ax squared and a bx piece, we need to find the value. That's what that blank block means. We need to find the value that would create for us this thing that's called a perfect square. All right? To do this, it's a very simple process. What you're going to do is take b, which is 18, divided by 2. That gives me 9, and square it. All right? Then I can write this as x plus 9 quantity squared. All right? That's completing the square. Okay? Take a look at the right one here now. Notice how there's a subtraction there. I'm going to take b divided by 2, which would be 12, negative 12, square it. That gives me 144. All right? Or let me rewrite that a little bit differently. Sorry, I can't find my eraser on my pen. 144 or negative 12 squared. I'm going to write it now as a factorization of x minus 12 quantity squared. All right? So we're going to be taking this concept of this thing that's called completing the square and taking it much further in our next lesson. All right, good luck. Let me know if you have any questions.